Hello everyone. We were talking about the block and tackle system, and in this video we are going to talk about the force distribution over four legs of uh, the derrick. You can see that in the middle we have the crown block and traveling block, and the lines basically to the block, and then the fast line is attached to the drawwork, and drawwork is located in the located between legs C and D. This is typical rig floor, and most of the rigs here we have the same kind of structure. So there is a fast line here connected to drawworks. This is leg C, this is leg D, and you can see that this load which is the fast line is applying to the derrick is distributed between only legs C and D. And the force which is applied by the system of crown block, traveling block, and the weights are equally distributed between four legs because it is in the center of the rig floor. And also the deadline usually is attached to leg A, so the force from the deadline is only imposed on leg A. So there is a different distribution of force between different legs, right? So if you look at this table here, you can see that the load source, the total load, and the load sources are the hook load, right? The weight of the stands, drilling strings, the fast line, and the deadline, right? So the hook load is W, as we mentioned previously, right? The fast line is W over En. Again, we mentioned this one in previous video. W over N is the force which is applied to deadline or tension inside the deadline, right? So the hook load, as we mentioned, is distributed between four legs. So if you have four legs here, you can see that it's W over 4 for each of them, right? And then the fast line is distributed between legs C and D. So half of this W over En will go to leg C, which is W over 2En. And the other half goes to leg D, right? So W over 2En. And then the deadline is only attached to leg A, so you have W over N for leg A. Then you can add them up, right, for each leg and calculate the total load for each of these legs. So which of these legs you think have the highest load? W is distributed between all legs, right? So leg B, that's the only force that is being applied to that leg. So this is kind of the lowest. Now, between leg A and B and C, again, the weight is the same, right? W over 4, but leg A have a deadline attached, which is equal to W over N here, right? And the leg N, C, and D, the fast line force is distributed between these two, which is W over 2En, which is less than this W over N. So leg A is the maximum load that being applied the maximum load is being applied to leg A between all four legs. Okay, and since if any leg fails, the entire derrick also fails, right? They define a force which is called the maximum equivalent derrick load. They call it FDE. And they assume that that force is basically it's 4 multiplied by the maximum derrick load, and that would be 4 multiplied by the force which is applied to leg A. If you do the calculations, do the simplifications, this is going to be N plus 4 over N multiplied by W. So this is equation 19 in the book if you want to go and look at it, but this is called an equivalent maximum equivalent derrick load, FDE. Okay, so now a parameter sometimes is used to evaluate different drilling line arrangements, and that is called derrick efficiency factor, and is the ratio of the actual derrick load to the maximum equivalent load. So if I want to define the ED, this is different from efficiency here. This is called derrick efficiency factor. So it's ED equal to FD divided by FDE, right? And I'm gonna just write it on the top here, FD over FDE. You divide these two FD, you have the equations for it, you have FDE equation, simplified, you get En plus 1 divided by En plus 4, right? These efficiencies are given in the normal efficiencies, which is E, is given in table 1-2 in the book, and we discuss those numbers, right? So you can calculate the derrick efficiency factor by just using those efficiencies, and also the number of lines. These two factors play roles here, right? So this is the equation for derrick load, right? And that efficiency that we were talking about, which is in table 1-2, which is this table here, right? These numbers you can also calculate it using this equation, e to the power of n, and e is just the is a number, right? And is called the individual sheaf efficiency. That's E. Okay, so if you have the E given to you, and you have the number of lines, then you can calculate the efficiency here, right? The overall efficiency of the derrick load. So I guess I'm going to stop this video. In the next video, I'm going to do an example on these calculations.